Hello, I'm Norbert Böbering. Welcome to the audio presentation of my paper, Induction of Tin Pest for Cleaning Tin Drop Contaminated Optics. My work is about the cleaning of tin drops on very sensitive optics by initiation of a phase transition. The main idea is to make a tin drop that fell on a coated mirror become very brittle so that its pieces can easily be removed by gentle puffs of dry gas. This scheme is illustrated in the photos shown here. The phenomenon is called tin pest, where during cooling, the normal phase of tin, shiny beta tin, is converted to brittle gray tin, the alpha phase of tin. Here are the highlights of my applied materials research. By induction of tin pest, the drops crack into pieces. High purity tin is required. The transition is faster for higher purity grades. Tin drops deposited on multilayer-coated optics disintegrate into pieces after transformation. Sensitive optics can be cleaned by the phase transition at minus 24 degrees centigrade. The reflectance of multilayer-coated mirrors is restored by this cleaning method. EUVL, that is extreme ultraviolet lithography, will be used to create even smaller structures compared to current semiconductor technologies. The required light at very short wavelengths is generated by a laser-produced plasma using high-purity tin inside of an EUV scanner. A drawback is that the expensive collector mirror is located very close to the plasma. It can be contaminated with tin drops and needs to be cleaned periodically. My new concept has several advantages compared to other cleaning techniques. In my experiment, molten tin is dripped through a hole in a copper plate. At some distance below, the drop falls on a metal plate or on a multi-layer coated mirror. The splash is then inoculated with seeds of gray tin. Samples are stored in transparent containers in a refrigerator at minus 24 degrees. The progress of transformation of gray tin is examined periodically using a CCD camera or a microscope. The area fraction covered by gray tin is then determined. To increase the conversion rate, in some cases the drops are also deformed or the surface oxide layer is removed. Photos show the evolution of tin pest on a drop with a purity of 99.99%. Shown is the drop right after inoculation and also after 9, 32 and 42 days of cooling. Deformation and cracking of the gray tin occurs due to its strong volume expansion of about 26%. This conversion is still fairly slow because of the influence of impurities. The diagram on the right side compares the transformation kinetics for several samples with different purities on a logarithmic timescale. For 5/9 tin purity, I could achieve the conversion in less than 24 hours. This shows my observations for a tin drop on top of a multilayer coated mirror when using tin of 99.999% purity. The full transition occurred in less than 22 hours. For another mirror sample, the reflectance of EUV light at around 13.6 nanometer was measured before and after tin drop conversion. The initial peak reflectance of 68% was reduced after cleaning by no more than 1%. This shows that this cleaning method does not induce any significant damage in the mirror coating. My tests have shown the conditions for tin pest induction with subsequent disintegration of tin drops. The degree of purity is an essential factor for the transformation speed. For the highest purity grades examined here, the transition could be completed on multilayer mirrors in just a few hours and always in less than a day. In this new optics cleaning concept, the mirror reflectance is restored without coating damage. I demonstrated the general cleaning concept by tin pest induction on small samples. Next, this should be applied to collector mirrors. The industry needs to improve the availability and the uptime of the light source in the UV scanner. To save time and money, the collector mirror should be cleaned in situ. It needs to be tested how the cleaning by tin pest can be done directly inside of the vacuum chamber without mirror removal. Please send me an email in case of questions or comments.